Welcome to another video of Embedded Blockchain. If you are new to this channel, I hope you enjoy our videos and don't forget to hit the like button and the subscribe button. If you are not new to this channel, then welcome back and don't forget to hit the like button. The memory map of a microcontroller is the layout of how the memory is structured inside the chip. Flash or RAM is used to store the code, the instructions for the program that you wrote. RAM is used to store temporary data. RAM is further divided by the compiler and linker in Heap, Stack, Global, Static. To understand a little bit more, we look at the RAM section of the microcontroller. This section is managed by the linker. It is broken down into the following sections. Heap. This memory is allocated dynamically, meaning the program allocates this memory as requested by the program. Stack. This memory is allocated for local variables inside functions. Every time you call a function, all variables inside that function must be assigned an address. This address is located in the stack section. Static or global. This memory is allocated for global variables, also when using the static modifier. The memory and sections are defined in the linker script. Here are some examples of the linker script. The memory sections are defining its origin and length. Then the sections are defined and assigning a memory to each section. This is how the linker knows where to put each variable depending on the data type you use. Let's look at an example. First, we have two global variables, total and total2. These are stored in the static global section. All global and static variables are stored in this section. Then we have two local variables inside the main function. These are stored in the stack section. Basically, all local variables to a function are stored in this section. Finally, all the program or all the instructions are stored in the text section. This is how the linker stores the program and the variables in memory inside a microcontroller. To understand the heap memory, we illustrate using an example using pointers and the malloc function. The malloc function allocates memory at runtime. It does so by using the heap section of the RAM memory. Since we are not referring to another variable that has already been declared, instead, we want our pointer to have a memory address of its own. The malloc function does this. It grabs an available address in the heap memory and assigns it to the pointer. Now our pointer has a reference in memory. This is also known as dynamic memory allocation, since it is done at runtime. This is how memory is managed by the linker in our C program.